all you cool bear cats and kittens. It's Miss Mollenauer here. I hope you're doing well. Today is lesson number 12, and we're starting a new method to solve a quadratic equation. So we've had graphing, we've had factoring, we've had the one we just did, the square root method, and now today we're doing the completing the square method. And so it's going to pretty much be exactly what it sounds like, completing a square. This is actually, I've been dreading this lesson on tape because it's kind of difficult. There's a lot that I would do in the classroom with you guys, a lot of things that we would do together to try and figure this one out. So it's okay if you're a little confused. It's okay if you're a little confused throughout this whole process. Again, not being in the classroom, I understand it's difficult, so just don't freak out about it. You'll still be okay. Again, always feel free to communicate with me, email me, whatever. So I guess let's just get started. One of the things that you need to know for today's lesson is one of those special factoring patterns. So that's going back all the way to the factoring. So I brought it up here on my tablet, and here we have our two special patterns. We had the difference of two perfect squares, and then we had perfect square trinomials. And the one that we're going to be looking at today is the perfect square trinomials. So remember, your first term was squared, and your last term was squared, and then your middle term was 2 times the square root of the first and last term. So there's a lot going on there with that middle term, but it didn't really matter when it came to factoring. You just looked at the first term, 100x squared, and said that the square root of that was 10x, and then you looked at the last term, 81, the square root of that is 9, and so then your answer becomes a binomial that's squared, and the sign was determined by the first sign of the trinomial. So if this one was a subtraction sign, then a subtraction sign went in the bubble. So I've got a couple review problems for you. This would have been like a bell ringer for you on the board. Today what we're looking at is those patterns, but when your leading coefficient is just 1. So factoring perfect square trinomials, when your leading coefficient is 1. So I've got a bunch of examples here. What you should notice is that the first term is just x squared, so that's a perfect square, and then your last term, 9, 25, 4, 121, 81, that's also a perfect square. Okay, remember this is our list of perfect squares right here, and then these are the square roots of all of those numbers. So that's what we needed for those patterns. And again, if we were in a classroom, I would have given this to you like a time test, you know, like you used to have back in the day. And I would say like, here, factor all of these, ready, go. And you would have like factored all of them as fast as you could. And this is a 3-minute little timer thingy. And whoever got the most right in the time probably would have got some candy. So we're just going to do with what we can. We'll do these together. So remember, a perfect square trinomial, that pattern, we like it because it factors easily. We don't have to do any work. 3 terms. When it factors, you just get one bubble that's squared. So for all of these, you're just going to get one bubble squared. The first term in the bubble is the square root of the first term in the trinomial. So the square root of x squared is just x. The sign is determined by the first sign in the trinomial, so plus. And the last term is determined by the square root of the last term in your trinomial. So the square root of 9 is 3. Done. Okay, that's why we could have done a time test, because these don't take long. They're patterns, so they can be done quickly. The next one, x squared plus 10x plus 25. That is a perfect square trinomial. First and last terms are perfect squared. Your middle term is 2ab. Square of the first term is x. First sign, plus. Square of the last term, 5. Quantity, squared, done. Okay. The next one, perfect square trinomial. Okay. Perfect square. And square of the first term, x. Sign, subtraction. Square of the last term, 2. Quantity squared, done. Okay, see how easy that is? So again, yeah, this should be coming back to you hopefully. The next one, a bubble squared. Square root of the first term is x. Sign, plus, square root of the last term, 11. Bubble, squared, square of the first term, x, sine, subtraction, square of the last term, 9. Bubble, squared, square of the first term, x, sine, subtraction, square of the last term, 1. Done. Okay, so that was factoring your perfect square trinomials. Hopefully that's coming back to you. If not, go back and watch that lesson. So we're going to use this today, and the reason that we like the perfect square trinomials is because they factor so easily. Like that took 0.7 seconds to complete. So what else we're doing, it's called completing the square. And so what I want to show you first, I have a YouTube video. So completing the square is basically you've been given some information, but it's not a complete square. So what do you have to do to make it a complete square? So here this lady has an example, okay, of x squared plus 4x plus 3. So the x squared term is represented by this green block. It's a square, x squared. So this side is x and this side is x. X times x is x squared. These yellow bars are considered your x values, like your, so this is your quadratic term, these are your linear terms. So you have 4 x's, so 4x. And then plus 3, these are your constants. So there's just those 3 orange little squares represented by those 3. So what you have to do to complete the square is take all of those pieces that you have, again this is something that we could have done in class, and rearrange them to make a square. And so I think that she does this here. Okay, yes. So rearranging all of those pieces to try and form a square. But what you should notice is that, move your hand, move your hand. Ah, okay, don't watch what she's doing now. Okay, we're just gonna. There. Okay, so but what you notice is that with that x squared, and those 4 x's and those 3 constants, is that there's still a piece missing at the bottom. It's not a perfect square. There's a piece missing. So what would you have to add to make that a perfect square? Well, you'd have to add one more of those little orange blocks. And then later on, she gives an example of x squared plus 6x plus 15. Using the same idea, you've got your x squared. This time you have 6 x's and then 15 of those ones. Again, create a perfect square. So manipulate those pieces to make a perfect square. You'd put 3 of the yellow ones on this side, 3 of the yellow ones on that side, and then fill in the block there with your 15 ones. But you would only need to use 9 of them, so you'd have some left over, so it wouldn't create a perfect square. So there's different things that we can do to manipulate that. But the idea behind this is this whole thing of making it into a perfect square. Okay, so these trinomials are perfect squares because it's a quantity squared. Okay, so I know I've done a lot of rambling, and a lot of times, especially now in a video form, this might just be easier if I do an example with you to show you how to complete the process of completing the square. We are going to use a little bit of the square root method with this. So this is an additional step to solve a quadratic. And before this whole chapter's over, like at the end, I'll go through like when to know to use what method. So like I said, you're going to learn 5 different methods to solve a quadratic. And it's helpful to know, well, if I'm given this quadratic, how do I know which method to use? I'm going to go over that with you, so don't worry. All right, so today, solving quadratic functions by completing the square. And that first bullet point there is completing the square. And it is the process that allows you to write an expression of the form x squared plus bx plus c as the square of a binomial. So the square of a binomial is just that. Basically, taking this trinomial and writing it in factored form, which is why we just did this review, okay? So completing the square, taking that trinomial and writing it as the square of a binomial. It follows the general rule. So here you go. You've got x squared plus bx plus c, and then that factors to x plus b divided by 2 squared. So what you should notice is that every perfect square trinomial that we factored earlier, when we factored it, that b value, that middle coefficient, that number is also half of that. So before I was saying what's the square root of the first term, x, what's the square root of the last term, 3. But it's also half of that b value. So half of 6 is 3, half of 10 is 5, half of 4 is 2, half of 22 is 11. So that's a cool little twist there to this. It's actually both of those things. It's the square root of the last term and it's half of the middle term. So one thing that you're going to have to do with completing the square is find the c value. And so I would ask you this time and time again, how do you find the c value? You're going to take half of b and square it. So example 1, find the value that makes x squared minus 3x plus c a perfect square trinomial. Again, this is something that we would have done with those little blocks that I was showing you that we would have figured out. So this might not make sense right now, but I'm sorry. I'm just going to have to like throw it at you here. So if I give you a perfect square trinomial, x squared, that would mean you have like one of those big blocks, okay? Minus 3x, so you've got 3 of those bars that are x. Plus c. We want to know, what do we have to add to this picture so that it creates a perfect square? Well, we could take 2 of these x blocks and put them side by side like that, but then if we move the other one down here, there's still a lot missing. We'd have to add 1, 2, 3. That's okay. Yeah, this one's just kidding. But something to this form where we'd have to add more to it to figure out what c is. I gave you a not so nice first example for the picture, anyways. So, how to come up with the value of c. That's basically how to know what to add to this picture to make it a perfect square. You take half of b, so divide it by 2, and then square that amount. So how do you find the value of c? Take half of b and square it. So in this particular one, our b value is 3. So to come up with our c value, we're taking 3 and dividing it by 2 and then squaring that. So that's why my picture wasn't so nice, because it's going to be a not so nice number. So order of operations, also hopefully from chapter 7 you remember those properties of exponents. Here we have the power of a quotient. So you can take both the numerator and the denominator and raise them to that power. So you don't even need a calculator for this. What is 3 squared? 9. What is 2 squared? 4. So the c value that would make this into a perfect square is 9/4. So you would need to add 9/4 of those little blocks to create a perfect square here. Not ideal, but that is the c value. So now x squared minus 3x plus 9/4. It may not look like it, but that's a perfect square trinomial. Okay, we just made that into a perfect square. And then that could be factored easily. So following this form here, x squared plus bx plus c, we just made that into a perfect square trinomial, and we like those so much because they factor easily. What this would factor to, kind of making a mess over here, is the square root of the first term, x, sine, subtraction, and then the square root of the last term, or, remember it's just half of b. So half of 3 is 3/2, and then quantity squared. Crazy example because mostly your b value was 3. Okay, it wasn't an even number. So when you divide it by 2, you have a decimal or a fraction. Let me just give you another example here before we move on to actually completing the square. Okay, if I have x squared plus 20x plus c, I want to know what that c value is to make this into a perfect square trinomial. Okay, what would make this into a perfect square? Well, how do you find the c value? Take half of b and square it. So, to find our c value, our b value is 20. So we're going to take half of 20 and square it. Well, what's half of 20? 10. What's 10 squared? 100. Okay, so the c value here that would make this a perfect square trinomial is 100. So now this is a perfect square trinomial, so we had to add 100 of those little pieces to this to make it into a perfect square. And then why do we like perfect square trinomials? Because they factor easily. So this would factor to the square root of the first term, x, sign, plus square root of the last term, or half of the middle term, which is 10 both ways, quantity squared. Okay, so really the only new thing we're doing here is coming up with that c value to make it into a perfect square, because we've factored perfect square trinomials already. All right, so let's just jump into an example. If your leading coefficient is 1, so it is important to notice that there will be a slightly different process to complete the square if your leading coefficient is not 1. So we're going to start completing the square, and your leading coefficient is 1. So we need to, basically we're trying to solve for x for this quadratic function by using the completing the square method. So step 1 is going to be set it up to complete a square. And I know that doesn't make sense yet, but so set, these are my own words, these are not technical, set it up to complete the square. Okay, so what I mean by that, if you take a look, x squared plus 10x minus 3 equals 0. Your first term is a perfect square. Your last term is not, however. Not to mention, if you look at your b term, we just learned that if we take half of that value, which is 5, and square it, which is 25, 25 is the value that would make that a perfect square trinomial, not -3. So what we need to do to set it up to complete the square is get rid of that constant that's not making it a perfect square. And what I mean by get rid of it is move it to the other side. So eventually what we're trying to do is solve for x. So since that is not helping us, we just want to move it to the other side. So I'm going to write the step out in words and then show it underneath that. So x squared plus 10x plus c. Okay, so I'm going to make room for that c value that does make this a perfect square. And then in that same step, that -3 that was not making this a perfect square trinomial, I'm going to move it to the other side. And to do that, I'd have to add 3 to both sides of the equal sign. So I'm going to add 3 to this side. But what you should notice is that over here on the left side, I also added a c. And whatever you do to one side of the equation, you have to do to the other. So just like I added 3 to this side of the equation, and I had to add 3 to this side, I added c, so I also have to add c to this side. We don't really know what c is yet because we haven't done the math, but we know that we're adding it to both sides. And so what I like to do when I'm completing the square, to know that I'm adding a c value to both sides, rather than actually writing the c, I just put a blank there. Okay, but it is the c value that we're adding to both sides. So setting it up to complete the square, you're moving over the value that has nothing to do, it's not making this a perfect square trinomial, so you're moving it to the other side, and you're creating a space for the value that will make it a perfect square trinomial. And why a perfect square trinomial? Because it factors easily. Okay, so that would be setting it up to complete the square. The next step is to find the c value. Which, how do you find the c value? Take half of b and square it. Okay, so in this case our b value is 10. So our c value is half of 10 squared. And half of, my dog, he's snoring. Half of 10 is 5, and 5 squared is 25. So now we're going to add that 25 to both sides. So we have our x squared plus 10x plus blank equals 3 plus blank. And we just found the blank. It's that c value, 25. So we're adding 25 to both sides. Okay, so that's step 2, plugging in the c value. Step 3 is going to be factor the left side, because we just made it a perfect square trinomial. So factor the left side. And simplify the right side. So basically do whatever math is over there on the right side. Simplify the right side. All right, so again, what we did was we made this a perfect square trinomial, and we like it because it factors easily. So we get that one bubble that's squared. The square root of the first term is x. Sign plus the square root of the last term is 5. Nice, right? Because that was easy because of the pattern. Equals, now simplify the right side. 25 plus 3 is 28. Now, okay, that was all the completing the square part, like we made it into a perfect square. Now what we're going to do is we're going to use the square root method to solve for x. So step 4 is use the square root method to solve for x. Use the square root method to solve for x. And the square root method, if you recall, is what we did previous to this. So we've got an x plus 5 quantity squared equals 28. And the key with using that square root method, let me just scroll up here. Boom, right there. Isolate the part that's squared. Okay? And so, if you notice, this is the part that's squared, and it's already isolated. So now, what we did then was we just square rooted both sides. Square rooting something that's squared cancels each other out. So you're left with x plus 5. And then on the right side, we're square rooting a number, so don't forget your plus or minus. So plus or minus is square root of 28. And then, if you remember, you need to simplify the radical first. So the square root of 28. Are there any perfect square factors that you can divide out of 28? Four. Okay, so simplify the radical. We've got x plus 5 equals, remember the plus or minus always stays in front because we're just rewriting the square root of 28 in a different method. So the square root of 4 times the square root of 7 is what we would break that apart into using the product property. The square root of 4 is actually 2. So we've got that x plus 5 equals plus or minus 2. And then the square root of 7 does not simplify. 7. So we get the square root of 28 becomes 2 radical 7. Plus or minus is still in front of all of that. Now we just need to get that x by itself, so we have x plus 5, so subtract 5 from both sides. So if you subtract 5 from both sides, remember this is all a part of a radical, the 5 is not, so they don't just combine. So your final answer should be x equals negative 5 plus or minus that 2 radical 7. And you're done. Okay, so I know that was a lot, but I'm going to do a couple more of the examples with you, and hopefully you catch on. Okay, let's just go for it. Example 3, solve by completing the square. So first of all, what you should notice is that our quadratic, our leading coefficient is 1, so it's just x squared plus 6x minus 8 equals 0. So first of all, we're trying to solve this quadratic for x. If we look at that b value, first of all, we need to determine if this is a perfect square trinomial already. Well, 8 is not a perfect square, so it's not. Half of 6 squared, okay, that's not 8. So we need to move that 8 to the other side. We need to set it up to complete the square. Step 1, set it up to complete the square. So that means we have our x squared plus 6x plus the blank, the c value that does make it a perfect square. And then what do we have to do with that negative 8, that minus 8 that's not making a perfect square? Move it to the other side. So we'd have to add 8 to both sides. So over here we're going to have a positive 8 because we added it to both sides, but also plus the blank, that c value that we're adding to both sides to make a perfect square. So there we set it up to complete the square, step 1. Step 2, find the c value. So our c value is, how do you find the c value? Take half of b and square it. So our b value is 6. Half of 6 is 3. 3 squared is 9. Hopefully that's the math that you can start to do in your head. 6, half of 6 is 3. 3 squared is 9. So 9 is the c value that we're adding to both sides. And step 3, factor the left side, simplify the right. The reason that we like that left side is because we just made it a perfect square trinomial. So it factors easily to one bubble that's squared. Okay? The square root of the first term is x. The sign is a plus sign. The square root of the last term, 9, is 3. Notice that 3 is also half of 6. Okay, it's the same. Equals, and then 8 plus 9 is 17. Next, we're already on step 4. Solve by using the square root method. So we can square root both sides because the part that's squared is by itself. Square root both sides. The left side becomes just x plus 3. The right side, we're taking the square root of just a number, so don't forget your plus or minus. The square root of 17, does that simplify? Does 17 have a perfect square factor? No, 17 is prime. So the square root of 17 is already simplified. So now all we have to do is just get the x by itself. So it's x plus 3. So subtract 3 from both sides. And remember, this is just a regular 3. This is a radical. Don't combine them. So x equals negative 3 plus or minus the square root of 17. And you're done. Sorry, my neck itches. Boom! See, that didn't take as long as our first example because I just had to teach you all the steps. So yeah, we just solved that by completing the square. And I need to move that so we can look at the next example. Ow! Here we go. Okay, the next example, 4, solve by completing the square. First of all, notice that your leading coefficient is 1. It's x squared minus 12x plus 36 equals 25. So there's a little bit something else different going on here. We already have a value over here. That's clearly probably not making it a perfect square, so it's already at the other side. So our b value is 12. And so 36 is a perfect square, but is it the perfect square that makes this a perfect square trinomial? Let's check. So that c value that would make it a perfect square trinomial would be half of 12 squared. Well, what's half of 12? 6. What's 6 squared? 36. Guess what? This left side is already a perfect square trinomial. Cool! So we just basically eliminated step 1 and 2. So now we just need to start at step 3, factor the left side, simplify the right, and then solve using the square root method. So you're going to factor the left side, which gives you x minus square root of 36 is 6 equals 25. Well, that was easy. And then the part that's squared is by itself, so you can square root both sides. The left side becomes just x minus 6. The right side, you're taking the square root of the number, so don't forget your plus or minus. Plus or minus the square root of 25. Why does my nose itch so bad? Ugh. Somebody talking about me? No, that's ears. Does that mean I'm going to get money? I don't remember. All right, so 25 is a perfect square. The square root of 25 is just 5. So x minus 6 equals, you still need the plus or minus, because remember it can be a negative 5 or a positive 5. So plus or minus 5. Oh my goodness. Okay. There's no longer a radical here. And this is just a regular number, and this is just a regular number, so we can combine them. So if we are going to add 6 to both sides, basically what that means is we have 6 plus 5 and 6 minus 5, because it's plus or minus 5. So we have a 6 plus 5 and 6 minus 5. What's 6 plus 5? 11. What's 6 minus 5? 1. So x equals 11 and 1. That one was a nice one. Okay. Number 5, you're going to do on your own. I might help get you set it up here real quick, though. Just the first step here. So x squared plus 4x plus 10 equals negative 1. Half of b squared, so half of 4 is 2, and 2 squared is 4. That's not a 4. That's not a perfect square. That's not a perfect square trinomial. So you would need to set it up to complete the square. So x squared plus 4x plus blank equals, and then we need to subtract this 10 from both sides. Hold up. Oops. So that would actually give us a negative 11, which we haven't talked about this yet. So, poop. Let's make this a negative 10. So then let's add 10 to both sides. That'll work. We'll do it that way. So then negative 1 plus 10 is 9 plus blank. All right, we'll do it that way. I apologize. I did not look through that carefully. What would have happened there, we would have had a negative number, negative 11, and then when we square rooted both sides, we would have been taking the square root of a negative, which if you remember from class, I talked about this a couple times. You can't take the square root of a negative because it is an imaginary number, okay? So that would have been an imaginary answer, and we haven't covered that yet. That's something you'll do more in Algebra 2. Example 5, you're going to do on your own. Kind of got you started there. Change that to a -10 so that we could add 10 to both sides and get a real answer. All right. I know that was a long lesson, but I hope you did well. Check your emails. I sent you all an email. Today is Friday, May 1st. I sent them to you yesterday. So have a great day. Bye.